talk about a few of these questions. First, I want to have some people share out some patterns that they saw.
The 11s are a diagonal pattern.
Okay. Anybody else write that down as a pattern that they saw? The 11s? Yeah. Another pattern that anybody noticed? Mark?
3 extends down to the left diagonally from 3, 6, 9, and then we extend that pattern going across. Down into the left
Oh,
diagonal.
got it. This way?
Yes.
It's down to the left. It goes.
Right. Anybody else write that down as a pattern they saw? Okay. Any other patterns? Carol?
Seven's a little bit. No, you did sit and choose to start extended like you go down on the next level, count over 2, there's 14. Count over
Yeah, it starts at 62.
2, 6.
Okay.
So down,
One.
down 1,
Over 3.
1, 2, 3,
And then down 1, over 3.
2, 3. And that works for all of them?
Yeah.
I was thinking
But the only thing is when you get to the end of the row, you have to take, say, your 21 there.
Uh-huh.
You have to go backwards 7. Count backwards 7 and start the pattern again.
Okay. So think about this, if we're going, on a hundreds chart it's nice, right? If we're going down 1, and then what are we doing? We're going from 14,
Adding 10.
we're adding 10, and then going back 3,
We're adding 7.
right?
Yeah.
So plus 10 minus 3? Somebody else had a pattern. Yeah, Adam?
2, 5, and 10 are all columns.
Straight up and down.
Straight up and down.
Columns. Good. Yeah. Cheryl. 2 has columns in those. Starting at 4. Okay. Any questions on any of that? So I want to talk about number 4. So we discussed kind of clarifying this question a little bit more. Find 5 composite numbers in a row so we can insert the word consecutive so the kids know that they're right next to each other. Did anybody find any patterns in those numbers? Julie?
If you start with 24 through 28, and then you add 30 to 24, it's 54 through 38, 58, and then add 30, 84 through 88. And if you do 32 to 36, add 30, 62 to 66, add 30, 92 to 96.
Interesting.
Each of these 5 consecutive numbers starts with either a 2, 4, or 8 in their ones column. So 24 starts, 32, 48, 54, 74, 62, and 84.
Okay, so we're gonna go back for a second for Cheryl. So what's the smallest set? So then can we start with 12?
No.
No,
Oh, no. You
24.
said 24?
Yeah.
So 1, 2, 3, 4, 5. So 24 to 28. And then Julie, you said add 30?
Yeah, but then there's 74 to 78. So
So-
I didn't take into account.
The next one is 32.
Yeah, 32 to 36.
36.
Okay. So I'm gonna go back to Julie's 4 and 8 really quick because Cheryl had a question about that. So 24 to 28,
Yeah.
and then we have
Then I just added 30 to 24 and got 54.
54 to 58 are 5 consecutive.
Then I added another 30 and got 84 to 88.
And then 84 to 88. Now what I would probably do is have my students go through and circle all the other prime numbers just so they kind of stand out a little bit more on the sheet.
Yeah.
That will help. So we had that pattern of a 4 and an 8 in the ones place, correct? And then the other one was 2 and 6.
32 to 36. Yeah.
So we have 32 to 36, and then we have
62 to
62 to 66, and then
90.
92 to 96. So it's just the patterns in the ones digits in those.
But there was that 74 to 78 that I didn't account for.
74. And technically, it could be 90 to 94 if you wanted.
Oh yeah, it could be 90 to 94, you're right. 90 to 96, wow.
Ooh, that's a big run though, 90 through 96. Cool. I love patterns. Patterns are awesome. Okay, so let's talk about number 6. How did you figure out which prime numbers divided 84? Yeah, you just looked at the markings, right? So this gets the students active. It also satisfies those kids who bust out their pencil box on the first day with the rainbow colored pens or pencils, and they want everything to be colorful, right? That was me. I took different days' notes in different colors.
You also need to eliminate 5 quickly. It's not 0 or 5.
Oh, good point. Okay, and then we got to, let's talk about number 8. What numbers are multiples of both 6 and 7? Well, we didn't sift for 6. So how can we figure out the numbers that are multiples of both 6 and 7?
2 and 3 marks.
2, 3, and
Must be
7.
2 and 3.
Good. So then we needed to look for numbers that had both pink, blue, and yellow, or whatever colors you're choosing in your classroom. So do you see how students can use this as a very visual way to start decomposing numbers? So I want you to take a moment at your table. So we have, and actually let's get a feel in the room. How many people here teach 6th grade? 7th grade? 8th grade? And high school? Quite a few. So these are where the really rich conversations come up because we have teachers from multiple grade levels. So I want you to talk at your table right now. This may seem like a very elementary thing to do, but how could this be useful for your students in your classroom? Okay, so we'll take a couple minutes and talk about that at your tables.
Well, I teach algebra class that we have divided up into 2 years basically, so we call it algebra 1.1 and then 1.2. So they're basically one semester in 1 whole year, and then second semester in the third year. So, I mean, these are kids with low skill sets, so this is something we definitely have to do with them, just because the number sense is so low. Probably do like week 1.
What you do is you just have to put a pattern or divisible by 3. What is the mathematical pattern? Because everything is divisible by 3 adds up to 3. Adds up to divide by 3. Do you have a follow that pattern or follow it?
I feel like you said this. You mean if they look at the pattern, you want them to look at it like a number pattern, or the colors that they see coming out?
Prime number pattern?
Is that what you're asking?
Yeah, I said visual. What I want to see the color, which is visual part
Yeah.
of it. Get staff to come up with a mathematical explanation.
I think it depends on.
Conceptual understanding. You don't feel that concept. Later on, they can.
Right, you need to extend it. You can't just look at the. So, when you subtract in your head, so when you take we take number charts, like 100 chart, and we teach kids to,
So that's
for subtraction, go to the largest number, excuse me, go to the smallest number, and you add up, and they use 100 charts. So when you do subtraction in your head,
5 and then 1.
you do the algorithm,
And then 5. Let me just leave it up. And then 3.
you look at it differently
Then it
because
goes 5 and 5, doesn't it?
it's not what you teach kids to do, and they don't touch it.
So it looks like,
So I try to get
except for down in the 90s, right, which is what we talked about, there's that.
they just
So this is actually an easier way to look at your 5 composite numbers in a row. Yeah. To look at clusters of factors.
and then distance between the numbers. And for a lot of kids, they don't like numbers.
Okay, take 30 seconds
Trying to
to
get
wrap
them
up
to
your
explain
conversation.
that more. So I think probably for someone like you, and a little bit neat. I didn't learn numbers in pictures like that. You know what I'm saying?
Yeah, because
So-
actually negative numbers are the biggest problem with algebra.
Brought up an interesting pattern that didn't come up in our conversation, and that's the pattern of the location of the prime numbers. So we just looked at the patterns in the composite numbers, we didn't talk about. And then when you have this, if you do this at the beginning of the year, this is, I think it's kind of pretty. And if you have themes in your classroom, you have like an aquatic theme, you can pick colors that match the theme in your classroom. But sometimes, we have to do, when back to school night happens, like right away. This is something nice to also have up in your room. And then it doesn't take up all that much space, and you can keep it and they can refer to it. But we said maybe this would have been a better place to look when looking at the 5 composite numbers in a row, because then you look at the clusters of 5 Post-its, right? So the nice part about the 100 chart is something they can keep and they can have and they can use it at home. But we can see the same patterns on the number line that we have on the wall as well. Anything anybody is burning to share from their conversations at the table?
Well, it's not like something to share, but just like, for the most part, we teach high school and we like struggling to figure out how we could apply this like in an algebra 2 classroom, for instance. And like I have an idea, like I know I have to do something with background. But I don't know. Are there any other high school teachers who like figured out?
High school teachers with suggestions on how, or non-high school teachers with suggestions on how you could apply this in your classroom.
High school teacher, we actually discussed the question that they asked of us. What's the lowest number of times you can get to find all the numbers? And don't give them a straight number. Give them a 7 by 7. Give them awkward ones that I haven't seen before, and have them do this over and over again, because it's number sets, it's mental math. So many of my kids can't multiply by 10 in that class, because they're so dependent on the calculator. That, just having a 0 at the end is not something to stop. Building number sense on an early, first day type activity made sense to me.
And when you said the 10 by 10 grid, I didn't get to it, but this is not a 10 by 10
No,
grid.
that's not.
And so how does that same idea apply to a number line?